Welcome to Section 8, Lesson 1. Section 8 is the factoring section, where multiplication starts with two factors and produces a polynomial. Factoring runs that operation in reverse, taking the polynomial and recovering the factors. Today's lesson is the very first step you should always try every single time before any other factoring technique. The greatest common factor is the largest factor that divides every term of a polynomial cleanly. It is the part that all the terms have in common. Once you find it, you write it out front, and what remains in parentheses is the polynomial divided by that factor. The GCF has two pieces. The numerical piece is the GCD of the coefficients. The variable piece is the lowest power of each variable that appears in every term. Multiply those two pieces together and you have the full GCF ready to be pulled out front of the polynomial. And the rule that follows is simple. Always factor out the GCF first before reaching for grouping, trinomial methods, difference of squares, or anything else. Pulling out the GCF first makes every other technique easier and sometimes makes them unnecessary. Let us walk through a small example. The polynomial is 12x cubed plus 18x squared minus 6x. Three terms, all containing x to some power, all with even integer coefficients. The job is to find the GCF and write the polynomial in factored form. Start with the numerical part. Find the greatest common divisor of 12, 18, and 6. 6 divides 12 evenly, 6 divides 18 evenly, and 6 is itself one of the terms. The numerical GCF is 6. Now the variable part. The powers of x are 3, 2, and 1. The lowest of those three powers is 1, so x to the first power is the variable GCF. Always pick the lowest exponent, because that is the one that divides every term. Combine the two pieces. The full GCF is 6. Pull 6x out front and divide each original term by 6x. 12x cubed divided by 6x is 2x squared. 18x squared divided by 6x is 3x. Negative 6x divided by 6x is negative 1. The factored form is 6x times the quantity 2x squared plus 3x minus 1. Now a problem with two variables. Factor 15a squared b cubed minus 20, 5a cubed b squared plus 10a squared b. Three terms, each one carrying both a's and b's. The procedure is the same: numerical piece first, then each variable separately. Numerical part. Find the greatest common divisor of 15, 20, 5, and 10. 5 divides each of them evenly. 15 is 3 times 5. 25 is 5 times 5. 10 is 2 times 5. So the numerical GCF is 5. Variable appears as a squared, a cubed, and a squared. The lowest power among those three is a squared, so a squared is the GCF for the a part. Variable b appears as b cubed, b squared, and b to the first. The lowest is b to the first, so b is the GCF for the b part. Multiply the three pieces together. The combined GCF is 5 times a squared times b. That is the factor we will pull out front, and it must divide every original term cleanly. Each term is going to lose a 5 and a squared and a b on the way out. Divide each term by the GCF and assemble the factored form. 15a squared b cubed divided by 5a squared b is 3b squared. Negative 20, 5a cubed b squared divided by 5a squared b is negative 5ab. 10a squared b divided by 5a squared b is 2. So the factored form is 5a squared b times the trinomial 3b squared minus 5ab plus 2. The GCF is not always a single monomial. Sometimes it is an entire binomial. Look at 3x times the quantity x plus 5 minus 7 times the quantity x plus 5. Two terms, and both of them contain the same parenthesized expression. The shared part is the binomial x plus 5. It is sitting inside both terms, multiplied once by 3x and once by negative 7. That binomial is the common factor of both terms, the same way a shared monomial would be in the previous problems. Pull the binomial out front exactly the same way. Write x plus 5 outside the parentheses, and what remains inside is 3x minus 7, the two coefficients that were multiplying the binomial. The factoring step is just one move. The clean factored form is x plus 5 times 3x minus 7. This pattern is the heart of factoring by grouping, which is the very next lesson. When a 4-term polynomial splits into pairs and each pair shares a binomial, the pull-out step is exactly the move shown here. 3 takeaways close out the GCF lesson. Each one is something you should reach for before any other factoring technique. The GCF has 2 pieces. The numerical part is the greatest common divisor of the coefficients. The variable part is the lowest power of each variable that appears in every term. Multiply them together, and that is the factor you pull out. Pulling out the GCF means writing it in front of a parenthesized expression. To find what goes inside the parentheses, divide every original term by the GCF. The polynomial equals GCF times the resulting expression exactly. The GCF does not have to be a single number times a single variable power. It can be a whole binomial like x plus 5. When 2 terms share a binomial, pull that binomial out the same way you would a monomial, and the rest of the factoring becomes straightforward.